I'll give you a quick overview of our agenda for today. We're going to start out by doing some quick introductions, give you an opportunity to test out your microphones, and we're also interested to hear from you what is your students' biggest math challenge? Since today's focus is on math and sharing some ideas and tools that will be hopefully useful for you when you're working with your students, and ideally something that you could even use this afternoon or tomorrow in your classroom. So what are you seeing with your students, their biggest challenge? And then we'll dive right into our content. We're fortunate to have Kathleen McNally from SREB with us today. She may be familiar.
Good morning.
Good morning, Kathleen. She may be familiar to some of you who have attended the TAP math workshops, and she has put together a great program for us today with a bunch of strategies and some considerations for you and for using with your students. So we'll start out by thinking about literacy strategies. Some of you who have been trained in max teaching or some of the other strategies and concepts related to literacy. How can we take those tools and use them to help students in their math work? From there, we'll move on to this idea of multiple representations of data. Those of you who shared with us typed sample sets of data, this is where we'll be talking about that. So how can we help students think visually about math and about numbers and manipulating information from one format to another? From there, we'll continue on and talk about some problem-solving strategies. So how to help a student who just has no idea where to start with a problem. What are some tips or tools that you can use to help them get started? And then finally, if we have time, we'll talk a bit about some Common Core math practices and how those can be applied and brought into your classroom to really take the next step to building math competence. So that's what we have on deck for us today. We would like to ask if anyone is sharing a computer connection with a colleague, could you please type in your names into the question box just so we can make sure to give you credit for your attendance today. And with that, why don't we go ahead and do just a quick introductions. I'll unmute your microphones and ask you to tell us your name, your school, and if you have any comments on students' biggest math challenge, we'd be very interested to hear that from you. Excuse me. So just go in alphabetical order by first name. I'm just looking at the list here. And we will start out with Charles DeBellis. Good morning. How are you today?
Good. How are you?
Oh, great. Thanks. Go ahead, please.
Okay. My name is Charlie DeBellis, Carpentry at the Career Institute of Technology, and with me today is also Dr. Roth, the director.
Great.
The biggest challenge, I would say, with math, the biggest challenge is still just simple fractions and multiplication, division.
Okay. Thank you, and thank you both for joining us today. That's interesting. We heard similar ideas on yesterday's session with the auto tech instructors. Some of the basics are where students are really struggling the most. So I suspect that some of your colleagues will probably have a similar response. So thank you. We appreciate your joining us today. How about Gary Fenton? Do you have audio today, Gary? Good morning.
Can you hear me?
Yes, go ahead, please.
My name is Gary Fenton. I teach at the Susquehanna County Career Technology Center, and I would have to agree with the last person and say fractions.
Okay. Great. Thanks for joining us today.
Sure.
Gary Kistler, good morning. Do you have audio today? Oops, sounds a little bit screechy there, so we'll circle back to Gary and see if we can get him connected. Greg Martin, I'll unmute you. Good morning.
Okay.
Good morning, Greg.
How you doing, Jennifer? This is Greg
Hi.
Martin at Monroe Career Technical Institute. I would say the biggest problem students have is the multi-step problems, going from one addition or one equation to the next.
Okay, thank you. Well, let's see, John Lewiski. Good morning, John. Do you have audio today?
Yes, I do. How's it sounding on your end?
Oh, sounds good. Go ahead, please.
All right. Well, I just want to introduce myself and Mr. Miller, who's here currently with me right now. Our principal, Dr. Kraft, is going to be here in a few seconds. But I think for me, teaching carpentry, the biggest hurdle that my students seem to have is converting from what they're going to start out with on a tape measure back to something they could type into a calculator and then back to the tape measure, so we can actually use those measurements. So I think it's along the lines of like everyone else is saying, decimals to fractions and back and forth.
Okay, thank you. And a very key part of what you're teaching. So very important for them to be able to do those translations. So great, thank you, and thanks to your colleagues for joining us as well. We'll go on to Kathy Houghton. Kathy, good morning. Would you like to share anything with us today, Kathy?
Okay, I didn't hear you say my name. Sorry.
Sorry, that's okay.
This is this is Kathy Houghton from the Technical College High School Penn Oxbridge campus. I had joined the webinar yesterday, and I've gone to give my same comment as I did yesterday, that I think our biggest problem is students' attitudes towards math. They just hear they're going to be doing math and they kind of shut down or just feel that they can't do it. So we need to overcome that part before we even start.
Thank you. And we did talk about that a little bit yesterday, and I appreciate that comment. Let's see, Mike Locke. Good morning, Mike. All right, we'll come back. And Nathan Stairs, good morning. How are you today? Not sure if your audio is connected. Oh, okay. We'll come back to Mike, had his hand raised. Mike, did you want to test out your microphone? I see your hands raised, Mike, but we're not, your microphone is unmuted, but we're not hearing you. If you would like to type into the chat box or the question box, my colleague Matt Fleck from Meter Consulting is online with us as well, and he can try to sort out the microphone. Okay. Nathan says he doesn't have audio. He's the carpentry instructor at Lenape Tech, and his students struggle with estimating materials. Great. Thank you for sharing that. We have, let's see, Philip Kinsell and Philip Rodson online with us. They've indicated that they don't have microphones today, but they have entered in a couple comments. One is that the biggest math challenge is basic fraction manipulation and decimals. And then another is knowing how to read a tape measure and fractions, even though we only concentrate on 1/16 of an inch and try to simplify the process as much as possible. So again, some of those same challenges that we've heard from other folks. Let's see. We have a couple more folks. Sharon, good morning. I unmuted your microphone. Would you like to say anything? Okay. Doesn't seem to be quite connected at the moment. Steve Weber, I'll give you an opportunity. Good morning, Steve.
Oh,
yep,
morning.
that's you. Good morning. Thanks for joining us.
Yeah, all of the above. Fractions, times tables, converting inches to feet, trying to get them to memorize your full times tables. Simple arithmetic is a huge problem.
Sure. Thank you. And is Lisa there with you as well? Would she care to add anything?
I am. I think transferring data, like knowing how to do it for the first time, but then transferring it to another situation, like not just knowing how to do it on the board, but actually being able to apply it.
Okay, thank you. Sorry, it's a little bit difficult to hear you this morning. If you could maybe move a little bit closer to your microphone or your phone. But I believe what I heard was transferring data is what you mentioned, Lisa?
Yes, I'm sorry. Between like actually theory work and transferring it out in the shop, the students seem to forget how to do that or can't process it in a different way.
Okay, interesting. So making that transition or leap between math theory and using it in the shop in a real life situation. Is that the essence of what you said?
Yes.
Okay, great. Thank you. And thank you both for joining us this morning. We have one or two other folks. Timothy Bash, good morning. Do you have anything that you'd like to share? Okay, let's just circle back to Sharon and see if we can. Good morning, Sharon. We have you unmuted. Would you like to introduce yourself?
All right. Yes, Sharon Dialing at Dauphin County Technical School. I'm here with Tim Carroll, our carpentry teacher, and we actually had a conversation before you unmuted us. We think that the biggest math challenge is just general number sense, which kind of encapsulates a lot of what's been mentioned before, that kids don't understand the size of numbers, how they're written, all those sorts of little things.
Sure. And would that also include just having a sort of an estimation of what the magnitude of the answer is to expect? Should it be 100? Yes. Should it be 100 or 1,000,000 or?
Absolutely, yes.
Mm-hmm. Great.
I agree.
Great. Well, thank you, and I'm glad we were able to connect with you. Is there anyone else who would like to test out their microphone that we didn't hear from yet? If so, just please raise your hand. Take a quick look. Okay. Well, I think we heard from most folks, and certainly appreciate your thoughts. And sounds like everyone has some similar challenges that they're facing, and we hope today to share with you some tools, as I mentioned, and some ideas on how to address those in your classroom. So with that, I'd like to turn over the program to our guest presenter, Kathleen McNally from SREB. She'll be sharing all of these wonderful ideas with us. And what we'd like to do is to have this be an interactive session. If you have comments or questions as we go, please raise your hand or enter those into the question box. We'll be taking a couple opportunities for some conversation, and we're definitely interested in hearing from you and giving you the opportunity to speak with each other as well. So let's go ahead and move forward then. Kathleen?
Thank you, Jen. And do I sound okay?
You sound great, loud and clear.
Okay, and you let me know if that goes wrong. And thank you to you and Matt. And really, again, I echo Jennifer's remark that we really want this to be interactive, so feel free to jump in. I'm just going to kind of be Julie Cruz director and share some things. Some kind of focus areas that we find that we're working on through the TAP initiative. So some of you folks have been working with me through that, and great to see you on the webinar this morning. So I thought we would be remiss if we didn't mention from our first webinar, or our webinar earlier in the year that focused on embedding math in CTE, about the research that was done years ago from the National Research Center, of which Pennsylvania was a big player. And what rolled out from that was a real sort of challenge across several states to look at developing math in CTE lessons. And I think no matter whether you are at a center that encourages or expects math-embedded lessons or not, I think there's a couple big understandings that we can walk away from that become the reason why the tools and the strategies that we're going to talk about this morning, I think, become so important. And so what's on the screen are the formal 7 elements for embedding math in CTE, and we did mention that last time. But what I'd like to do on the next slide is suggest that there are 3 big implications to anybody that is teaching from this work. And the first being that we know there's power for students to bridge or however you want to say that, to make connections with them and for them between the language of the field and the language of mathematics. Because mathematics has, by nature, acts like a language. It provides you an opportunity, it provides people tools to talk about your intuition and your wisdom and your knowledge. And so it acts like a language. And students, we cannot assume that they translate it. I mean, we see it all the time where they come from a math class and they're in a construction class and they don't necessarily make the connection between what they were doing in their geometry class and what they're doing in their construction class. And so the idea of bridging language and terminology is a big understanding that we took away from that work. The second is the idea of it really helps students to have opportunities to see both the world of mathematics traditionally, which is what you think about in a math class, in a math textbook, on a math test, and contextually, which you folks have wonderful opportunities to do and you do well. So to make the marriage, though, and have them see it together is really helpful. And the third implication is just that they found through the study that students tended to get more out of having the math that's naturally within the world of CTE or within construction and carpentry be the opportunity for them to practice and get some understanding around it, so that it's easier to come at it that way than theoretically for many, many students. So those are the three big implications, and I just wanted to set the stage with those as we move through these different tools and ideas, because they are meant to support all of these things. So I think the first area, if I may, Jennifer, this slide, is around this idea of supporting math understanding but through literacy strategies. So it'd be interesting to see if you come from a center that's involved with the TAP initiative, then you may very well have been down the road in literacy training or max teaching. So maybe we can get a sense of that, Jennifer.
Sure. Could we ask you to click on the hand icon to raise your hand if you have received any sort of training on literacy strategies, max teaching, Cornell Notes, any of those through an in-service or perhaps a TAP program. Please just raise your hand to a quick straw poll here. Let's see, 2, 4, 5, 6, 7. Looks like a little bit over half of our participants are raising their hand, Kathleen.
Okay, terrific. So there's lots of food for thought. So there's lots of tools out there floating around and strategies to help students with navigating the world of literacy and technical literacy. Well, now our idea and what we see working is to use those in the max teaching strategies, but for a math understanding. Because the Common Core State Standards, which is now kind of our focus in Pennsylvania, has two big things, and one of them is this idea of procedural fluency. So that's what folks are talking about when they're talking about number sense and being able to, I love that idea from John about taking something from a tape measure into the calculator, back to the tape measure, and making sense of all that. Yeah, that's what we mean when we talk about them being fluent with procedures. The other piece of the Common Core is the goal of getting students to understand the concepts that underlie that. So attacking fractions from a conceptual standpoint is a little bit different than attacking fractions from a procedural standpoint. And so often students don't get enough of the conceptual, and so they don't get a real sense of what fractions are. And so if they forget the rules or they're trying to flip them over, it just gets to be a mess. So hence this is what this is about. So some of these literacy strategies, and we'll start with the next one. Next slide. Great. Okay, so here's one of our goals, this idea of bridging the gap. And you folks have really rich, you talk in a very rich technical way, roof pitch, run, grade, incline. But on the math, if students were working with the same mathematics concept, in their world it's slope. They may hear change in y over change in x, that kind of thing. So we want to try to bridge those things together. And here's a couple ways to do that. Thank you, Jennifer. Yeah, so some of it is the idea of within your fields is to really, and sometimes I think it's great to do this in a partnership with a math colleague, is to really brainstorm and find those opportunities, those technical vocabularies that have some math meaning. So what are the words in your regular world, in your construction world, that really come at it from a math perspective that you talk about? And here's some great examples on the screen, and I think we have some others. And we would ask folks to provide some of those. So this is a great list that Jennifer put together. Yeah, so overhang, the idea of square, which is great because the square means square, but it means square in a different way in math, but it's the same thing. Super. So to take these opportunities, these different vocabularies in math meaning, and really get into the concepts of that, helps students in a broader sense. So I think our next slide introduces a set of tools. Oh, no, wait. Go ahead, Jennifer. We're going to ask them a question.
Sure.
Yeah, let's go to the next slide and see what they say.
Sure. And if I could interrupt for just a moment, I wanted to share a comment related to this. Steve Weber typed into the chat box. He says, it's not really about going from math class to carpentry. It's within the program, and we just need to integrate the language. So sort of an additional thought on that.
Terrific. Thank you, Steve.
Okay. So as we're laying the groundwork for this idea, I wanted to pose a question to our PLC participants. When we asked folks to share examples of vocabulary and some of the other things that we requested in preparation for this webinar, a couple instructors mentioned that they use composition books in their classes either for math assignments or writing activities. And we were curious to see if anyone is doing exercises where they're combining a math problem with a writing exercise, or if you have any thoughts on how that might be put into practice. If you have anything you'd like to share on that, please raise your hand or type it into the chat box. And while you're thinking of that, I'm going to unmute Charlie. He has his hand raised, and I'm wondering, did you have something that you wanted to share, Charlie? Go ahead, please. Your microphone is unmuted.
No, I didn't.
Oh.
I thought my hand was down.
Okay, we'll put it down. Thanks. Does anyone have any thoughts on or examples of something that they do where they're having students work with words and numbers in a combined assignment? Let's see. Kathy Houghton has an example. Kathy, go ahead, please.
Yes, as a matter of fact, it's not related exactly to carpentry, but it was something that we had done at our last TAP math workshop with Kathleen. She had given us talking points to be the math-related talking points. And what I did is I brought a lot of them listen to me, brought them back to school and typed on, put them in an Excel spreadsheet, and I actually shared it with the whole school, not just carpentry, where they could do like a journal topic, something that maybe when the teachers are doing their attendance, they can kind of have a math topic that they can write about. And some of them are just, explain a paragraph, about how math and science are related. So it's not necessarily program specific, but it is something that's math related.
Great, thank you. That sounds like a great resource for all of the instructors. Thanks for sharing that. Does anyone else have something that they wanted to share? Greg, thank you for raising your hand. Greg, go ahead, please.
Yeah, how you doing, Jennifer? I use an actual textbook to fulfill a lot of the math. It's called Practical Problems for Carpenters. I think it's through Cengage. It's an excellent book. It goes through about 43 units. And each section of the unit has a smaller section that actually deals with all the problem solving that the kids actually have to read and try to figure out.
Okay, and so then do they record their answers in a journal type book, or how do you put that into use on a day-to-day basis?
Yeah, sometimes I might actually pick one of the more complicated problems and have the kids actually write out the steps that they take to figure out the ending answer.
Mm-hmm. And is this something you do once a week, once a month?
It depends on the scheduling and stuff. I try to maybe once a week. Sometimes it turns into maybe once every 2 weeks.
Sure. Okay, great. Thank you for sharing that. And we have one additional comment. Tim typed into the question box that He says, my students have been writing 100-word / 500-word assignments. I will give them an assignment to reduce the word count by a percentage. Might not be too intense, but it helps them work out math problems. And he adds that all assignments are kept in the student electronic file and emailed to him. So using technology to enhance the connection. So thank you for sharing that. Okay, Kathleen?
Great. All really super examples, So I think, if I may, Jennifer, the next slide is sort of getting at this idea of how journaling or writing, physically writing about the mathematics involved in the construction projects and problems really helps students on many, many levels. And on the screen from SRAB are the 6 goals we have around that. So if we can use an opportunity for writing, as Tim said, you know, and it's great that he has that in electronic file, this idea of having them just summarize or even categorize, predict some things, recognizing vocabulary. Those 6 areas, research has found that students doing those, really focusing on those, as Kathy said, you might have just starters, just kind of general questions to get them to write, and that's the goal, is to do that, those 6 areas. And I think we have an example of a kind of a structured journal approach, because journals mean different things to different persons. I think before that, Jennifer, if we go back, there was it's an additional, right? You have it in your files. It's from Parkway West.
I'm sorry. Yes.
No, that's okay.
Not reading your mind there.
There we go. Yeah, folks were saying how they can journal, and Parkway West is willing to share these to these. You may have seen these before, or you may do something similar to this. So each student keeps a professional journal. They have determined what they're looking for in terms of requirements, but if you scoot down, the neat part is that you can use this as an opportunity to infuse mathematics. So now some of their prompts, like this one on the screen, is just about, you know, being a celebrity, but if you cruise down, the different program areas have made different prompts that are more specific to, say, construction or automotive. And they've also included employability skills, and notice that sometimes they have key vocabulary. So this one about, do you agree about installing solar panels on a roof of a house? Would it lower the heating system, you know, the costs? So it's an opportunity for teachers, and teachers individualize these for their program areas, but they're all doing this in a very sort of formalized way. So that's one. Thank you, Jennifer. So that's one, and we can post that so you have that as an example, correct?
Correct.
On the good, on the SAS. So that's one example. There's others, though, that I see, like I know Steve and Lisa at Reading Muhlenberg, they use journaling a little differently, where they'll have students literally working through problems for the week, and they keep thoughts of their problems, which is another neat idea to journaling. So it's not necessarily writing thoughts, but it's writing their math processes, which I think is another really interesting way of journaling. Thank you. So the next slide is, will show us, yeah. So I wanted to have folks kind of debate this just a little bit. If you're involved with the TAP initiative right now, like if you're currently in a literacy training, folks are focusing on, and the LDC in the title stands for Literacy Design Collaborative, and the goal there is to help CTE teachers and students make connections between what they're reading, either from textbooks or from journals, research, and then writing. And so on one side of the blue box is the idea of a prompt, a writing prompt, that takes on the form of the Literacy Design Collaborative is trying to encourage. On the right side is a more traditional prompt. And I'm curious from our audience, Jennifer and Matt, maybe if they have thoughts about, do they feel one is more rigorous, do they feel one is more user-friendly, if they have a sense of either or. I'd love any kind of comments about what they're seeing about these example prompts.
Sure. If anyone has a thought or a question about this information that you're seeing on the screen, please feel welcome to raise your hand or type that into the question box. I also see that Gary Fenton had his hand raised a little bit ago, so I wonder if we might start with him and see if he had a comment about using journals or something related. Gary, I'll unmute you. Did you have something, Gary, that you wanted to share?
Yeah, I just want to make a comment on the last question that we asked. I put my hand up at the very end.
Sure, sorry.
We do something similar to what Greg does with the worksheets out of the practical math book. I find that the students have the hardest problem deciding when the question is being asked written out what math is being used. What are they asking you? Division, multiplication, subtraction, whatever it may be. So at the beginning of the school year, we'll go through a bunch of sheets and we'll have them read through the problems and then decide and write in a division sign or a multiplication sign if they're asking how many hours a week did someone work for how much pay or whatever the case is. But that seems to be the problem, is that they don't really know what math the question is asking them for the word problems. Based on this slide here, what I do is, part of my job is building a house with our students, so a lot of journaling is done over at the house project. Each student has their own book, and that's where I get most of my feedback from, what they're actually picking up while we're building the house. And they do a lot of this writing in the journal as to what we have done or what we have just built. We just finished drywalling the house, so I would tell them in 50 words, complete sentences, give me a description of the process of drywalling the ceiling, or the process of drywalling the walls, or explain to me why we use moisture-resistant and mold-resistant drywalls in bathrooms, or whatever it is we're working on, and they would then, write at the end of the day. They get 15, 20 minutes at the end and put something on paper.
Sure, that's a very rich example. Thank you, and it's sort of a preview of one of the skills or strategies that we'll be talking about in a few minutes, the idea of getting a process or documenting the steps. So thank you for sharing that. It looks like Sharon has her hand raised. Let's go to her and see. Sharon, go ahead, please. Did you?
Hi. I was also going to comment on the last one, but I can comment as well on the writing task. As far as a way to use some writing in math, you could do some things like justifying your answer. Why are you doing the steps that you're doing? Kind of like what the last gentleman was saying about reading and looking for the operation. That's kind of annotating as you're going. But then also in a multi-step problem, why did I do this step first? Why did I do that step second, and so forth? Or even presenting a student with a problem that you've solved, that maybe you put an error in, and can you identify the error and explain why, where the error is. And then if you're looking, I'm looking at the screen, and I'm seeing the LDC writing task looks to be a lot more rigorous to me. And it's based on more than just what we talked about in class. It's based on researching, so which to me is kind of what happens when students leave school. You can't always, there's not always going to be a teacher to go ask a question about. So how can I go get information in another way? And that seems to be what the writing task is asking for. Also, now they have to set up an argument and justify their argument, support your position with evidence from the text. So again, supporting saying, not just this is how it is.
Super. Thank you, Sharon. Does anyone else have a comment that they'd like to share? Okay, I don't see any addition. Oh, Sharon, did you have something else? Yeah.
I'm sorry, I meant
okay.
You turned it off. I didn't.
No worries. Okay, Kathleen, go ahead, please.
Thank you so much, and thank you to Sharon and the others. Great thoughts for sure. And so keeping in mind, and I love this idea of what Gary suggested, like deciding what math to use and having students practice saying, is this a multiplication situation? Is this a division situation? that is a very rich opportunity to do that, and I think that's great. And the fact that Gary has them journaling about the house process, I mean, that's terrific. Those are great, great examples. And just on the screen before we leave this, keeping in mind that, yes, this is a literacy writing prompt, right? It's a writing reading prompt. But mathematically, you could absolutely encourage students that as they're journaling about their construction projects, the house project or whatever, that they have to include math thinking is their justification, because that's not unheard of. If folks would say, well, how did you get those figures? You know, what you're coming in with your bid, and your bid is outrageous, and why is it so different than these other contractors? You know, they have to be able to really bring in math thinking and math work in terms of forming a position. So I think there's real opportunity for kind of intersections here, and I thank everybody for their thoughts. They're dead on. Thank you. So the next idea that I think in the world of literacy, and our folks were getting at this, now this is just a little levity about how you cook a turkey, and these are like 5-year-olds, and I just wanted to give you a moment to see how they would describe the process of cooking a turkey. And I think there's another set. Yeah. Now, now I know it's a bit silly, and Zach is right though, when the bones are sticking out of the legs, it's ready. So, but the idea is, and you folks have hinted at this, that there's an awesome opportunity in the world of construction technology and construction trades to really insist that students help to document and write about processes. So how did you do that? How did you make that decision? So the steps that one would take in order to, you know, do a certain part of a job. It's really a rich exercise for them, and especially if they have to turn it around and somebody else has to try to follow it or use it. So I'm curious, Jennifer, if we can encourage folks to, you know, raise their hand if they have some examples of how they've done that before. It would be really neat to see if folks, I think the next slide invites them to do that. Yeah, so if we can, let's see if anybody has a specific suggestion on how they've done that in terms of having students journal about a process or the steps to doing something.
Great. If anyone has a thought that they'd like to share, please feel welcome to raise your hand or enter that into the chat, or the question box rather, and we'll be able to share that with the group. We heard one example a few moments ago. Tim, let's see. Go ahead, please. I recall, I think that your microphone maybe was not working, so if you could please type your thoughts into the question box, I'll be happy to read them. Has anyone else done this type of an exercise with their students, asking them to write out the steps in a process and perhaps then having them follow the process to see if it works? Tom, go ahead and test out your microphone. Tom, go ahead.
Can you hear me?
We can, yes.
Okay, great. Sorry I got on a little late. We had another thing going on at the school here. I work with level 1 students, first-year students, so we're going through a lot of introduction into tools, and as a part of our learning guides, I've incorporated procedure sheets into them, and basically it was step-by-step, but now I'm kind of having the kids take each step as kind of like notation, and then drawing that into a complete paragraph. It could be how to change a circular saw blade, or how to use the table saw to form a dado joint. We just finished up the router, installing an edge profiling bit, and it challenges my students from taking things in note form. They know the steps, but when you actually have to expand upon that and put it into sentence structure, the kids were a little bit resistant in the beginning because, you know, some of them don't have very strong writing skills, but you work with them, they get a little bit more comfortable, they have success with 1 or 2 sentences. The next thing, it's 3 or 4, and I found that if you stick with it, and week in and week out, you work on developing sentences and then drawing them together. Normally, by the end of the year, they're actually looking for that type of assignment by the end of the year.
That's a great example. Thank you for sharing that. We have a couple other folks who've entered some thoughts into the chat box. Philip Rodson writes that I have a lesson I have recently used where I have plans for 3 different shaped slab foundations. I use the same 3 shapes in sequence. First, to figure out the perimeter so that the amount of material needed to make the forms can be calculated. Next is to calculate the square footage or area of the forms. And finally, to figure out the cubic yards of concrete needed to form the slabs. This exercise relates directly to, and it's cut off, but I believe it says to the trade. Steve Weber notes that they just did process logs or journals for installing door closers. So some great ideas there. All right, Kathleen, any other thoughts on that?
Absolutely. Thank you so much, Jennifer.
I'm sorry. I'm going to add one more. Tim did type in. He says, I have taken the example of making a peanut butter and jelly sandwich, have the students write out a work order step by step, then exchange them to have someone actually make the PB&J to illustrate the importance of detail. Thank you, Tim, for typing that in. Okay, Kathleen, I think that's over to you.
Great, thank you so much. Wonderful. Oh, those are so neat. Excited about that. Great, great, rich understanding. Thank you. So the next slide, we have just a few more kind of literacy tools to wet your whistle about. This one on the screen is about the idea that I see folks, students may wrestle with terminology and concepts that again, remember those initial lists that we showed of the world of construction and how many of those are math rich and have math understandings behind them. And so I see some teachers gravitate towards the idea of a word wall. They may be encouraged to do that, and those are great things, kind of those visuals, and you see posters in program areas that have descriptions and so on and so forth. And I was thinking of supersizing this to the next step of really encouraging students to, this is almost like engineering tools, where they show connections, almost like flow charting, but in a little bit of a different way. This idea of word webbing, tools of the trade, and I wanted to throw this out to folks for consideration, that in the area of construction technology, measurement and all that entails is huge, and we need students to be really fluent in that and comfortable with that, so that they're, they grab a pencil and they're writing right on the wood and calculating this and that. And I think there's an opportunity to challenge students to visually show connection between different concepts. So this is just an example of the world of measurement and how you could create a word web that would have the different, if there's a lot of measurement in length. And I'm curious, so if folks can type in the chat box, if we can invite them, Jennifer and Matt, to do that, to see what could you add to this, or could there be another area, maybe tools, for example, that students could create a word web that would show the interrelationships. So I'm just curious about some thoughts. If folks want to type those in, we could keep moving, but I'd love to hear about that.
Okay, great. Please feel free to type in your thoughts, and as we see ideas coming in, perhaps we can take a pause in a few minutes and come back and review those.
Super, thank you. So that's another idea of like having students make the connections between the concepts and the terms and the the understandings behind that. And so different areas within the trade that would be rich for that. The next tool, I think, is another one of, it's one of my favorites because it really works mathematically, and some of you may use this, would love to hear it if you do. So it's a literacy tool, a classic literacy tool called the Freyer model, but it's also very useful mathematically because it gets at and encourages and invites students to think about a concept, but to think about a concept at a deeper level. So as you see by the design, the concept would go in the center. So if you think about what might be a huge concept in your world, like square, is something square, you might put that kind of concept in the middle, and then students, whether individually or in teams, are challenged to complete the model. So they're, in their own words, they would define it in the top left. They would think about what the characteristics are of something that's square. They would either draw or describe examples and non-examples, which is really powerful for students in terms of understanding the concept in order to have them classify what is and what is not the concept that you're after. For example, what is square and what is not square, and could they show or create an example? So that's yet another literacy tool that I think has real merit in terms of use for math understanding. Jennifer, did we have any comments on either one of those come in?
Let's take a quick look. I don't see any at the moment.
Okay, super. So this idea, I think that we're heading into our next area, are we not? Or do we have, if I may have the slide? Oh, yes, so this is terrific. So this is folks sent in sample word problems and wanted to show this as an example and see how, for example, any of the literacy strategies or your literacy approaches could support this example of a word problem. So I wanted to throw this up on the screen. This came to us from the team at Reading-Muhlenberg, and see if anybody in the audience has some ideas of how they would apply a literacy approach, any that we talked about or any that they do. So could we give them a moment to do that and see if anybody has thoughts?
Sure. And I'll just take a quick look here. It looks like Tim Bash has typed in that he uses the Freyer model and he likes it as well. Does anyone have other thoughts or comments related to the last few tools that we've talked about, or this idea of incorporating literacy or writing into a word problem exercise? Not seeing any hands raised at the moment, but if folks have ideas as we go, please feel welcome to type those into the question box. Okay. In the interest of time, Kathleen, may I suggest that we continue on?
Yep, we'll keep going. I just want to make one quick comment about this one. This idea of this word problem on the screen is that from a literacy standpoint, because several folks have made a comment about students not really knowing how to, to decipher it, like what do we need to do. And it's so rich in terms of there's a visual, which is kind of a lead into our next set of strategies, is that you can decide. I think it's really important. Einstein has said, we need to invite students to really also define the problem. And I think what was nice about this is the authors made a note that said, you can decide how much of this information you start with. So maybe you start with just the picture. And you say, how, let's talk about what we can think about in terms of how much money, and let students develop the questions that support the problem. Thank you. So our next area, we'll just keep launching and then folks can jump in, is this idea of multiple representations. So research in mathematics also shows that it's important to give students, invite them to have an opportunity, and I'll pull up the next slide if we could, is this idea of translating and transferring opportunities for data in one setting or one form to another. And this is a kind of a template that I encourage with the TAP groups to use and experiment with. So for example, students may have, as several of you said, you have different resource books, math problems and carpentry, and so you may practical problems. So you may give them a problem, which would be in words. And then the idea is to ask them or challenge them to say, if the word problem is, can you show what the word problem is after, either symbolically or in a table or a graph? So the idea is to ask students and challenge them to move from one multiple representation to another. So I think, Jennifer, what follows are some samples of data, and I think that they're graphical. Yeah. And wanted to show these to folks and have them kind of make some notes, so maybe we can give them just a moment to soak in each of the next few slides and then see if they can offer a suggestion of how you might go from the representation that's offered, like the lumber dimension chart, and what other form you might have them take on. So let's pause right here for just a moment and let them soak that in.
And if I could just add, this is a combination of items that were submitted by PLC members as well as some visuals that I found by doing a little bit of Googling, just trying to put together some examples for you, and we've given the locations online for all of these as well. So as we're looking at these, does anyone have any thoughts or examples that they've used in their classroom to work with students to either capture data from a real-life situation or to take information from one context and transfer it to another? Or if perhaps you haven't yet, does anything that you're seeing here give you a thought on how you might want to try that? I think I have one or two more. Anyone have thoughts or comments on that? If you do, please raise your hand or enter that into the question box.
You know, Jennifer, while folks are thinking about that, could I potentially show an example that came to me?
Sure.
It's on my laptop.
Why don't
Okay.
Yep, I'll change over presentation to you, and while that is taking place, I believe that Sharon has her hand raised, so we'll unmute her. And Sharon, did you have a thought that you'd like to share? Go ahead, please.
Yeah, I think it had to do with the graph on lumber prices. I recently did work with my culinary teacher where we were looking at the change in price of an ingredient over time, just like that lumber graph, and we're able to use that to, we actually took and put in what's called a line of fit and use that line of fit to predict what would happen to the price in the future. Wrote an equation for it, which would be your multiple representations that you were talking about.
Sure. And did you do that with pencil and paper, or did you do it using Excel, or both?
Kind of a combination. The kids were actually more familiar with and you know, and so they with that. And it worked. Now, as a math person, I had to do a lot of the leading through because the culinary teacher was not familiar with the equation part. And that was okay. We worked on it together, and we both came out of it learning some things about each other's areas.
Sure. That's a great example and sort of an innovative way to bring in some math that is not necessarily the typical culinary math example. So thank you for sharing that. That sounds like something that could easily be adapted to other classes as well. Kathleen, did you care to share the example that you have?
Sure. And I might turn it over. I know if Lisa and Steve are still online, this was their effort, and they shared it with me. They're so willing to share everything, and that was a great example, by the way, that we just heard about with the line of fit. That's awesome. So folks are on fire with this. But yes, this idea of multiple representations, and I'll certainly turn it over to them if they want to comment. But I wanted to point out that this idea of estimating, this estimating project, and the distance that a job is, and estimating the cost of a job. And notice the instructions on, if you see the screen, says construct the linear equations for the problem, draw the graph, and create a table for the carpenter from the following clients. And I'll flip through this, and they may want to say something, but I wanted to show. So notice that there's an opportunity for students to take a scenario and build a chart of, like, what do I know? Here's the name of the client. Here's how far they are. and then they go on to calculate. Notice that, isn't that great? And then, ta-da, they are able to create, and there's these linear equations. If they graph the project cost, it actually becomes these equations. So they may want to comment, Lisa and Steve may want to comment, but notice this little thing down here. They can choose, you can choose to give folks as much or as little information, but I think it's a very rich example of multiple representations, that students are creating charts, they're creating graphs, and they're taking it all from this written scenario.
Fantastic. Steve
and Muhlenberg team.
Sure. Let me unmute Steve and Lisa. And would either of you care to expand upon this example, or tell us perhaps a bit about where the idea came from? You're unmuted. Go ahead.
I guess I'm gonna. Can you hear me?
If it's a little bit muffled. Is there any way you can?
Any better?
A little bit. Are you using a microphone or your computer?
No, we're using it from the actual computer, so that's a struggle.
Okay.
To be honest, Kathleen kind of went through what it is, and I'll tell you where I actually came up with this first. I was an accountant for 15 years before I started teaching, and one of my small businesses I worked for had this issue come up that she was charging fees and never getting the customers. So when we were thinking about this and about how we could apply lines and graphs, this was one of those real-world examples where, being out in industry for the years I was, it came kind of back to haunt me, and I thought about it. So this is something we came up with. Unfortunately, we haven't actually done it with the students yet. So this was a very quick thing that came up with in the last week, and we're going to apply it in the next 2 weeks and see how the students handle it as far as what they're doing. But we're always looking for things with this algebra keystone to come up with to try to build it into programs, because you don't want to teach things that aren't relevant to the students.
Great, thank you. That's a great example, as you said, of bringing in that real world scenario to make make use of those concepts. Kathleen, did you have anything else that you wanted to add related to this example?
No, I'm so sorry. Thank you for the control of I have a dog problem. Sure. Sorry. I'll be right there. But thank you for giving me the screen, and I'll get rid of the dogs.
Okay, I'll take the...
Who let them out, by the way?
Hey, I think that's a song. All right, I'll go ahead and turn the presentation back to our slides. And did anyone else have additional thoughts about the graphs or any potential uses related to that? Multiple representations? Okay, and just to refresh your memory, this is the chart that Kathleen shared, and again, all of this information will be posted to the SAS community site, so you'll have that as a reference point, and you're of course welcome to make use of any of it in your classrooms. Let's see, do we have Kathleen back with us?
Yes, I'm here.
Okay.
Can you hear me?
Yes, we can.
Sorry about that. I had to let the dogs out. Forgive me. Oh, thanks for your patience.
Sure.
So yeah, were you chatting about the different multiple representations?
We just I just reviewed that table or that form that you had put together, and then moved on to this sample word problem. And just curious if you had any thoughts or comments related to this.
Just another example. I just wanted to throw that up, and folks will have these, right? And
yes.
SAS will be uploaded. So yet another example of how you can cross over between the written and the visual, and really giving students an opportunity to practice that. So
sure.
Thank you so much. So this idea of multiple representations, I think, was our second area. There's real richness to encourage students to do that transitioning. So the idea of a line of best fit, the idea of building in some linear equations, and even on less sophisticated level, I know that folks at the beginning were talking about, well, you know, students have trouble with fractions and they have trouble with, you know, converting stuff on a tape measure. Well, multiple representations can really help with that, to encourage them to give them a problem and then say, how does that fraction, how does that look? You know, you're chopping up a piece of board. What does that look like? And having them have to visualize it. So in a nutshell, I think it's kind of a great world in terms of, you know, the construction world to bring in some of those opportunities. Thank you. So I think we're ready for our next one, yes?
Okay, yes, and I would also just like to thank everyone who has shared examples with us, and I took a little bit of liberty in reformatting things a bit for purposes of our slides, but we definitely appreciate everyone who has contributed, and the original versions of your resources will be posted to the SAS site as well. Okay, so just taking a quick look at our time, it's 10:30. We have roughly half hour remaining on our session today, so we'll get through as many of these problem-solving strategies as we can, and if there are parts that we don't get to, we'll try to cover those in our next webinar session in April. Where to start?
Okay, thank you so much. So I will try to be succinct. But again, yes, this is the golden question. So there are opportunities abound for when students are presented with a rich scenario or a rich task. And I use that language very purposely because with the Common Core State Standards in Pennsylvania for mathematics, it's really hard to get at the practices and the content of what the Common Core is aiming for without rich examples. And so our job is, as a designer of instruction, of construction instruction, is to really look at how we can develop rich problems. But teachers will say, well, you know, I have problems with that because I'll present students with a really, you know, I've developed this, you know, kick-in scenario that's really rich and multi-step, and they don't know what to do. They can't get off first base. Well, that's what we're helping. These are very classic, fairly well-known problem-solving strategies, but the difference is the level of challenge for us as a community is to really say, okay, so how do we model these and how do we get out there and expect students to use them? So that instead of being very open-ended and just saying to students, we'll give it a try, go, is that this next section is about looking at these collection of problem-solving strategies about how can we start a problem or how can we make sense of a problem, and asking students to practice these, and sometimes it takes the teacher to model them. So there's a list real quick, and then I'll go, there's a slide for each one, and then I encourage folks to kind of, you know, get in there and let us know how you're doing it. So guess and check, obviously in construction, developing a picture, making a model is very powerful. Patterns, lists and charts, the idea of working backwards. And so all of those offer opportunities, and our goal is to figure out how can we build these strategies right into different assignments, and how can we help model them and then expect students to try them and show each other how they work. So for each one, the first one being the guess and check. Yeah, so what does that mean, guess and check? And I think on the screen, Jennifer, next is going to be an example. Yeah. Okay, after that, yeah, there we go. Now, it's not a construction example, but it's meant to show sort of what that means by guess and check. In fact, I have a carpentry example, and I will upload it to the SAS for you. Forgive me for forgetting that I had one that was presented from a Huntington group in one of our TAP sessions. But this is an idea where students are literally given a problem, and they're not exactly sure, and so the estimation kicks in where they try something. So they'll try a situation and say, what does that tell me? And it kind of look at their guess and go back to it. So I'll give folks a moment to read the problem. Okay, so for students to understand like how many rounds did this team win is to try one. So they know there's 25, so they could just literally take a guess and then say, does the guess work? And they would go back to the criteria in the problem and say, well, if they tied 3 and won 2 more than they lost, does it fit the scenario? And when they get it, and if it turns out that it's too big or too small, the idea is that they learn from their guess. They learn from their estimate, and they figure out how to do a better job, a better guess next time. So I think there's real implications here for construction. The next problem solving is the idea, strategy, I think, right, is this idea of modeling and taking a picture. And I just threw this in because it was a great problem that was provided by one of the PLC members. And I think it's, really appropriate for students to say, well, boy, what do I do? And they could literally draw themselves a picture, and it wouldn't have to be a picture to scale necessarily unless you want it to be, but it's this idea of giving them a visual to hang on to. So this is a great, I think, an example for where drawing a picture would help. And then we have our next strategy.
Sorry for my erratic clicking. I didn't know if there was a second bullet point on there.
No, that's okay. That's all right. Your clicking is great. So this one, looking for a pattern. So I'm going to let folks read through this. Okay, so how many days did it take for everybody to get together? It's kind of a silly scenario, but I love the fact that they're going to Florida. So the 100 reps, and so looking for a pattern would be that this is a scenario where students know data that there's one person, and then there's 10, and then there's 19, and then there's 28. And so for them to study that and say, okay, is there a rate? There's a similarness to the rate of growth of how many reps are getting together, so they can use that as an opportunity to figure out how to solve the problem. And in this case, I believe we have the answer.
Should we ask folks to type in the answer?
Oh, sure, if you want.
You'll see who's paying attention still at this point in the webinar. Go ahead and type into the chat box
what you think the answer is. Yeah, how many days does it take for everybody to get together?
Anyone willing to take a, we have a hand raised. Okay. Let's see.
Awesome.
Sharon, did you want to say anything?
I hit the wrong thing.
Oh, okay.
It's 9 days.
Thank you.
I had to type and I can't find it.
That's okay. All right, we'll do the big reveal here.
Thank you, Jennifer. So 12 days. So yeah, it's a silly example, but it's an example that we can look for opportunities within construction problems to say, is there a nature in there? Is there something where we can have a scenario where students have to use a pattern? And sometimes rates are great opportunities for that. Rates of pay, and saying, look, if I make this much for one job, or I'm costing it by, the hour, how do I know that? And so if students don't know that's multiplication, they can look for a pattern. The next tool, or the next strategy of getting them started, is a real classic make a list or chart. And so this was the idea of using some of the work that folks submitted, this price of lumber, and saying, could students, if they were challenged to have to make a judgment about this chart, or they were asked a question about it, they could literally make a chart to say, in what years, for example, was the real price of lumber under 400, for example. And that's, I think, under 400. So they could take this information, and if they didn't know where to start, they could definitely make a list or a chart. And then finally, I think we have working backwards. Yeah, and there's a scenario here. Okay. So I want folks to take a minute to read that one.
Kathleen, you must have the travel bug. You have all these examples of going to nice, warm places.
Yeah, for sure, for sure. So this gentleman, Jack arrives at 2:45, and the question is all about when he started his trip. And so the idea is that students would be required to work backwards. So you would start at the fact that he ended at 2:45, and then subtract. And I was thinking, in construction, wouldn't it be neat to find opportunities to create problems where students had to price a job, but they knew that the client had a maximum number, like I can only get to so much money, and then they would have to figure out with materials and labor and all that stuff, could they work backwards to present a potential scenario that would work within the confines of something. Those are the types of problems that are rich with working backwards. And so I think, if I recall, we have our list again. So I wanted to open up the floor. Oh, I'm sorry. So this is a jump start. So here's an example, a great one from CIT, from Charles, and this idea of estimating blocks. right? So I'm curious from the folks if there's any of the problem-solving strategies that students might be able to use for this scenario of estimating block problems if they didn't know where to go.
And there are a lot of components to this particular example, so perhaps there could be multiple.
Yeah, absolutely. That's why I put it in there, because it's really rich. There's a lot going on. Yeah. So any ideas if folks want to throw in the chat box about the estimating block, or if they have an example that they've used of how we would strengthen and encourage students to use these problem-solving strategies, in particular guess and check, looking for a pattern, either creating a model, using a chart, working backwards, any of those. Would love any feedback on folks that use them or have an opportunity to have a good problem that they've used. Let's see if we have any takers.
Sure. If anyone has a comment or something that they'd like to share related to that, please raise your hand or type into the question box. I imagine that many of these ideas are somewhat intuitive and perhaps aren't listed on a wall somewhere, but I almost wonder if there could be some sort of a like a cheat sheet type of tool or resource that could be used if needed with students. Try this, try this, try this. Has anyone done anything like that?
Absolutely. In fact, a school that we're working with in Kentucky, that's exactly what they're doing, is that they've partnered some of the AP students, the math students, with some of the technical courses and those students, and they're partnering to create sets of posters that exemplify the idea of the problem-solving strategies, but they're specific to, construction and graphic design and agriculture. And so they're using it as a student project, but they're doing exactly that to show these in action, because they are, as an adult, the folks that are on the webinar, these are intuitive. But for students, they may not think about what techniques they could use to help themselves.
Sure. Why don't we see if maybe Charlie can tell us a little bit about this sample problem that he shared. Charlie, would you like to share with us when and how you use this in your class? You're unmuted, if you would, please.
Right. Well, this is part of the one of the tasks in the 1200 series, with just the estimating. So as far as to try to get something simple enough, but yet bring in a lot of the different areas on how to figure. They can make a picture. They try to understand that an 8x8x16 block, with the mortar joint, naturally, it's 8 inches by 8 inches by 16, and you can relate it to studs, for 16 on center. There's a variety of things you can do with it, but the main thing was 3 block high is equal to 2 foot, and 3 block long is 4 foot. And then just by going ratio and proportion, or figuring it out, dividing, there's a number of ways you can go about it,
Great. Thank you. I wonder if there would maybe even be an additional application. Would it be practical to perhaps have a sample block there and have the students start by measuring it to see what size it actually is before they even get to this point? So just a thought. Okay.
Yeah, I mean the actual block is only going to be 7 5/8 by 7 5/8 by 15 5/8, because your 3/8 is your mortar joint.
Mm-hmm.
Right.
But you could even do conversions to everything to square inches. Finding the area. There's a number of ways you can build off of this, but this is just one that I had come up with.
Yeah, it's great, Charles. Thank you so much. I do. I really appreciate the richness of this, because there are lots of ways you can go. And I was just thinking in terms of problem solving, that students could actually, draw a picture. They could get themselves, kind of figuring out, okay, using the 8x8x16. But they could also, I also thought the same thing, that you could literally chart the proportions. So once they get that idea that 3 is, it's 4 foot long and 3 foot high, and how that looks, that they could keep track of that information in a way that helps them. So there's lots of, I think, built-in opportunities to use those different strategies. Thank you so much. Thank you, Jennifer.
Great. Thank you. And this is just a review.
So yeah, this is just a kind of, this is just a summary of these different opportunities. And it would be great to encourage the PLC community to look for what are some great rich problems that they're using that we could use to support, we could share. For example, on the SAS site, have some guess and check problems, and to have a make a model problem and look for a pattern problem. Because these are, but yet the difference is that we use the problem to help students with the process, and we invite them into where to start, these different opportunities for inroads. So that's the point of this third area. And I think we're at the point, Jennifer, of kind of launching into, I know we don't have much time left, so kind of to summarize, we had the 3 areas, right? We had the areas of literacy and how we maximize that, the opportunities for multiple representations, and then this third part about problem-solving strategies, helping students on where to start. And our goal across all of those is to keep experimenting with those and using those, putting those on our, in our sites, on our radar, and seeing what we learn from how they help with math understanding. And I'm not sure if you feel like that's an opportunity to kind of share some resources and for next time, or if you want to keep going. It's up to you.
I think, it seems like a sort of a natural stopping point for today's session. I would like to share, or perhaps give Steve Weber the opportunity to share a question or comment that he typed into the chat box. Steve, I'll unmute you. Would you like to, you typed in an interesting thought about explaining to students multiplying length and feet. Would you like to share that thought? You're unmuted.
How he explained that if you multiply the length in feet times 0.75, it tells you how many block are in a course, or studs in a wall spaced 15 inches on center. My students have a tough time grasping that.
Okay, does anyone have a thought or an idea on how to help get that concept or help students grasp that? I don't see any hands raised at the moment. Let's see. Oh, I'm sorry. So Kathy had a tough time hearing. If I can paraphrase, how can we help students grasp the concept or get an intrinsic understanding that multiplying the length in feet and multiplying by 0.75 tells them how many blocks are in one course? It's something that students seem to have some difficulty getting an understanding of. Has anyone done anything specifically with that scenario? Unfortunately, I'm not seeing any hands raised. Kathleen, do you have any thoughts on that? Any of our tools that we've talked about today that could help?
I think it sounds like, and I can certainly, if I may, I can pick Steve's brain offline so I can understand the dilemma, and then certainly we could send it out. I think if I'm I just want to make sure I understand the question. So multiplying the length and the feet, there seems to be a factor there, 0.75, so 3/4, and you're saying multiplying that by the length in feet gives them the number of blocks. So I just want to, because I can't hear very well, so I want to see if I can get the nuance. So if Steve's willing, maybe he can send me a quick email offline, and I'll work on it with them, and then we can share it back out. That'd be great, because I need a moment to understand it a little better.
Sure. Steve, could we ask you to connect? You can actually, perhaps if you could send that to me at our PLC at Meter Consulting email, and then I can share that with Kathleen and the perhaps the other math coaches on the call. So thank you for that. Why don't we take an opportunity just to see if there are any additional thoughts or questions, comments related to any of the ideas that we've shared today or that we've talked about. Any clarification that you'd like on how to use or put any of these into practice? While you're thinking of that, I'll just go ahead and jump to our resources and talk about some next steps. So these are what we're showing here are two websites that you may care to take a look at. Kathleen, could you comment on these, just what folks might be expected to find on these math sites?
Sure, yeah, they are definitely mathy sites. I put that in parentheses, but what I think is very helpful about both of them is that they're right in line with the Common Core State Standards for Mathematics. In fact, the authors of the Common Core are involved with the website development and upkeep, and they continue to add things. And both of them offer some opportunity for some examples. So if you're charged to look at the different content areas of high school mathematics, like I remember Lisa mentioning we want to get algebra concepts more in, then this is an opportunity to go there and look, and they have illustrations of the standards. So you could go to the algebra standard, for example, and they would have some illustrated problems and examples that might trigger some ideas of, okay, that's how I might be able to relate to it. One of the sites also has, a collection of math problems, like problem of the month or problem of the day, so that folks can pool on those too. So I think they're worthy because they're, kind of high end. They're not, there's lots and lots out there, and I think sometimes it's tough to find. So I wanted to encourage that if folks wanted additional resources about the actual math content, these are pretty good sites to look at. Thank you.
Great. And just a reminder as well, if you have sites that you use, this is to our participants today, that you'd like to share, please send those links to us via email, and we will add those to our resource directory on the SAS website. And here's a refresher on what that looks like. We're building up quite a nice collection of math resources there, and we're actually going to be working on categorizing those and making those more accessible. So look for that to come. Quick thoughts on some next steps. Our final webinar for this year will take place in April, specifically April 23rd from 1:30 to 3 o'clock, and the link for registration is in the March PLC newsletter that you received, and we'll send out some reminders as we get closer to that date as well. The topic is sort of open-ended. We've left it that way intentionally so that we'll be able to come back and cover any additional topics that have come up over the course of the PLC series. As we alluded to earlier, we have some information on some math practices that we like to share, and unfortunately didn't have the time for today. So look for that. And then also, if you have other topics that are related and you'd like to hear about them, send us a note. We'll see if we can line up some speakers to cover that. We also have your input from the survey that you completed a couple weeks ago. So we'll be looking to gather additional information for that session. And then finally, if you are planning to pursue Act 48 credits, just a reminder that we'll need you to complete and submit your webinar response form and have that sent back to us via email by next Tuesday, the 19th. The template for the response form is available on the SAS community site, or if you have a hard time locating that, you can send us an email and we'll share that back with you. So, looking at the clock, I think we have just a couple more minutes. So does anyone have any closing thoughts or questions or comments that they'd like to share today? Let's see. Looks like John has entered that April 23rd through 25th is our NOCTI performance testing dates. Is that the case for others as well? Do we have a potential schedule conflict with that? If you could raise your hand if that date is going to be a conflict for you. April 23rd. Okay, I see a couple of folks saying NOCTI is a different week. I know that's a tough time of year, and we try to be cognizant of all the different testing dates and spring break and all the different things that happen at the busy springtime of year. Some folks are not sure, and looks like NOCTI week for some. So why don't I send out? I'll send out a poll via email to folks, and we'll see if the majority of folks will be able to make that week. It looks like we don't have a lot of options for switching the date around because some folks are doing it the week before and some after. So we'll see if we can accommodate. But we are recording the sessions, so if you're not able to participate live, then we'll make an effort to get that for you. So thank you for bringing that up, and we'll follow up on that to see if we can accommodate. All right. Well, with that, we appreciate your time and contributions today. I'd really like to thank our guest presenter, Kathleen, for sharing all these great ideas and prompting some great discussion and thought sharing and hopefully some tools that you'll be able to take back and put into use in your classrooms. We'll look forward to meeting with everyone again in April, and hope everyone has a great afternoon, rest of the day. Thank you.